Okay, so for this video, we are going to go through the proof for the product rule. The product rule is initially given right here, but let's go through why that product rule exists and why it makes sense in the first place. So, for this proof, we start with this statement. Base c to the power of this exponent, log base c of x, times base c to the power of this exponent, log base c of y. Well, what's another way that we can write this product of powers? Well, one thing we can do is notice that they have the same base, right? Same base, c. And because they have the same base, we can represent this product of powers as simply one base. One base where we take the sum of each of the exponents. Right? So here, this base c had an exponent of log base c of x. There it is. And we're going to add that to log base c of y because that was the exponent on the other power. So hopefully this first line makes sense. C to the power log base c of x times c to the power log base c of y should just be c to the power log base c of x plus log base c of y. That comes from this property of exponents. Then we can say that because c to the power log base c of x is really just x, that comes from one of the basic properties that we learned last video. So because c to the log base c of x is just x, and c to the log base c of y, what is that? That's just y. Because of those two facts, we can say that c to the power, c to the power log base c of x times c to the log base c of y is just x times y, right? Because here, and let's maybe do a little color coding of this, because here we can see that log base c to the power log base c of x is really just x, and we can see that c to the power log base c of y is really just y. So this product is really just x times y. So hopefully it's clear why that's true. But if we take the product of these two powers, we just get x times y. So we could say that because c to the log base c of x times c to the log base c of y is equal to c to the log base c x plus log base c y, then it's also equal to x times y, as demonstrated here, right? So this is from the transitive property. We know that c to the power log base c of x times c to the power log base c y is equal to c to the power log base c of x plus log base c of y, which is also then equal to x times y. So hopefully that line is relatively clear. We are getting some meaty, beefy expressions going on here, so it takes a while for it to all click. But this is our next line. We see that c to the power of this sum of logarithms is just equal to x times y. Now, this is written in what we could call exponential form. This is written in exponential form. And we know that we could write this statement equivalently in logarithmic form. So what would this statement look like? What would this statement look like in logarithmic form? Well, in logarithmic form, we would say log base c, right, because c is our base here, log base c of some input would be equal to, well, what's the output of a logarithm? The output of the logarithm is the exponent in the exponential form. Right? So this exponent is going to be the output of our logarithm. And what's the input of the logarithm? Well, the input of the logarithm is really the output in your exponential form. So xy. And that's where we get this last line here, right? This logarithmic form of this exponential form is really just this last line. Log base c of x times y equals log base c of x plus log base c of y. And that's what we have here, right? So that's how we get this product rule for logarithms. Now, what we could say here is that the logarithm of some product is really just equal to the sum of the logarithms of the factors of that product, right? So here we have a product with factors x and y. The logarithm of this product of factors is simply the sum of the logarithms of each of those factors. So that's what we call the product rule for logarithms. So for example, let's say you have something like log base 3 of let's say I'm having trouble thinking of an actual 6 log base 3 of 6. So how could you split this up into a sum? Well, you could say that log base 3 of 6 is really log base 3 of 2 times 6. Sorry, 2 times 3, which would be equal to 6. So these two statements should be equal, right? Because 6 is equal to 2 times 3. And how could we split this up? Well, we could say this is really just the sum of the logarithms of each factor, right? So we have a factor of 2, so log base 3 of 2, plus, well, we have a factor of 3 here, so log base 3 of 3. And this is a random example, but we could actually, this is a good example for showing how we could simplify further, because log base 3 of 2, I have no idea what that is. I mean, I have some idea of what this is. It would be less than 1 and greater than 0, but beyond that, I don't really know what this would be. You would need a calculator for it. But log base 3 of 3, that would just be 1, right? 3 to what power gives you 3? 3 to the first power. So we can expand this sort of original logarithm in a way that might prove useful for solving some sort of problem. But in any case, that's the product rule. So log base c of x plus log base c of y, and then we might start to think about what might make sense for a corresponding quotient rule, right? If the logarithm of some product is really just the sum of the logarithms of the factors, then the logarithm of a quotient, well, that shouldn't really be a sum, right? If multiplication is related to addition, then the opposite of multiplication should be related to the opposite of addition. And so we should get log base cx minus log base c of y in this particular case. So this is actually the quotient rule for logarithms. If you have the logarithm of a quotient, that's just the differences, the difference of the logarithms of the numerator and denominator of that quotient. And the power rule, I'll just write it out and then I'll explain it more later. But the power rule is basically this. We can just rewrite log base c of x to the power y. We can rewrite that as just log base c of x. And what we can do is we can take this exponent that's on y and we can just move it down in front of this logarithm as it's, you could say as a factor of this logarithm. So log base c of x to the power y is really just y times log base c of x. And so these are the big three rules for logarithms. And in the next video, I'll go over a little bit more of an explanation of the quotient rule and the power rule. Not necessarily giving the most detailed proof, but hopefully giving you an idea at least of why they're true.